Hi, I'm Ryan. Today we're going to build Baby Tetris. And I promise that even if it's your first time doing hardware, by the end of this video, you'll be able to make it. Before we start, I just want to thank all of you guys for the comments you've given me since my last video. You've left me comments like this every single week, and it's because of you that I am back. And I will make a video every month, and I'm going to try to make them more frequent. And they're going to be a lot more fun videos. I love robotics. So thank you guys for all of your support. And you tripled my subscriber count since my last video. If you want to jump ahead, here are the timestamps. First, we're going to go through the parts list. And if anything changes, let me know and I'll update the description below. Then we're going to get our software ready. I'll show you how to solder it, then how to add MicroPython to the chip. And then instead of just showing you how to add the code to run Baby Tetris, I want to show you how I work with hardware. We're going to build a hello world program to know that the chip works, then one to know that our buttons are wired correctly, and one to know that the display works. When all those are done, we're ready for Baby Tetris. And if you're here to the very end, I'll even show you the code and we'll walk through what ChatGPT and I wrote for it. These are all the parts we're going to be using. We have the Seeed Studio Raspberry Pi or RP2040, and this is the only thing we're going to be soldering. We have a breadboard, a couple of buttons, we'll have half a dozen wires or so, and the monitor. It's important to get the right monitor because different ones use different libraries, and I'll give you a link in the description. And there's only one thing off screen right here, and that's the soldering iron, but that'll come up soon. All of the links for the software will be in the description. And the first thing we're going to do is come over to python.org and make sure we have a new version. We just need Python 3. And when that's done, we're going to go over to tawny or thawny.org and just download the version for your computer. You can also download MuEditor, but it causes problems on my computer. So I'm going to be using Tawny. Okay, here's the easiest trick for soldering. I need to put these pins on, and I want to make sure they're all flat and level. So what I first do is see how many I need. I'll clip it right there. That'll fit perfect. I'll do the same on the other side. I'll clip it right there. That'll fit perfect. And now I'm just going to put it right into the breadboard. We want to turn our soldering iron basically as high as it gets. We're going to use a lot of heat for a little time, and I'm not going to burn anything. I'm just going to touch the pin, and people will say touch the other side with your solder. It's okay, just touch your soldering iron. I'm going to touch the pin, and there we go. Touch the pin for 2 seconds, and there we go. Touch the pin, touch the soldering iron, just add enough. That's a little too much. It's okay. There we go. And we're going to do the same thing on this side. The soldering iron's going to touch the pin, and the solder, it can touch the pin or it can touch the soldering iron. Either way. And once you get the hang of it, you're really only on it for 2 seconds at a time. Now it's time for the fun stuff. We're going to play with the chip. Before we put this into the breadboard, I just want to make sure that everybody is on the same page. Horizontally, the 5 pins are all connected, then the divider, and then 5 pins are connected. And then when we have the ground and power, vertically, every ground is connected to each other, every power is connected to each other. So we're going to take this chip and plug it in across this dividing line. And now we have to install the MicroPython firmware. We're going to hold down the bottom right button. It has a B next to it for boot. So when you want to boot into it and then put in your power, you'll see on your computer a new drive called RPi-RP2. Next, we're going to open up Tawny and go to Run, then Configure Interpreter. There's a small link down at the bottom to install MicroPython. So I'll click that. It should automatically find the RPi-RP2 drive. For variant, we're going to use Raspberry Pi Pico H and just the newest version, and then install. Okay, that's done. I'll close And now we're ready for our first hello world. So all of the code is in the description, and I'm going to grab hello world chip and paste it into here. And now I'm going to click save. I'll choose Raspberry Pi Pico, and you have choices of 2 file names, not the ones on screen. It's going to be code.py or main.py. Those are the only ones that can run from the chip. So I'll choose code.py. On yours, you'll have to type it in. I already have code on here. Just click OK, and I'm going to overwrite. Okay, so next we're just going to press stop and then run. I always press stop just to get in the good habit. And now run. And hello world works, so the chip works. So now I know my chip is good. I can start building upon it. Okay, so we're going to wire these 2 buttons up. And what I want to do is make sure that when I press down, what I'm doing is connecting that leg to that leg and this leg to this leg. I want my button wires to be the same color as each other. I'm going to plug one of them into the top left pin, the other one into the pin just below. And whenever I work with hardware, I always keep this picture up. This is a pinout diagram. I don't always remember what pin goes to what. I never know what pin goes to what. I use these diagrams. Now, pin 26, I'm going to attach it to the top leg of the first button. And then I'm going to attach black for ground to the bottom leg for the first button. And I'll attach the other side to ground. And for the next pin down, I'll attach that to the top leg for the next button. I'll take another black for ground and attach that to the bottom leg for that second button, and I'll bring that over to ground. Now all we're missing is power and ground. Power is the first and the third pins on the right side. This one's 5 volts, that one's 3.3 volts. I usually like to work with 3.3. So when I work with power and ground, I always twist them together so it's easier to work with. And ground is the second pin. 3.3 volts is the third pin. I'll take those 2 and I'll plug them in to power and ground right here. And this is going to be our hello world for check buttons. So when we open up the hello world buttons program, we can see button left, pin 26, button right, pin 27. What's happening here is button left is the top left, button right is the pin right below it. And we're going to always check the buttons and then sleep for 5/100ths of a second. Inside of check buttons, this code's a little weird, but this is connected to ground. So if it's not a left value, goes low, then that means left has been pressed. And if it's not 0, a right value, that means the right button's been pressed. So I'll press stop, save, and run. And now left pressed, right pressed, left press, right press. So there's something important for you to change on yours based on your experience with this hello world, is how long do you wait to check? Because I only pressed it once and it showed twice. And there's 2 issues. How long am I waiting between checking and this debounce? So when the signal changes, it might bounce a little and we wait before we check again. So we check, we wait 100 milliseconds, and we check again after this loop goes. So if you see issues when you get to Tetris, change these lines in the real code. So before I plug this in, I just want to go through the orientation. I want to make sure that your pins don't get put in this way. Make sure that every pin gets its own horizontal line. So I'll plug them in like this. And you can see that from my previous hello world, all of my equipment's gone, the wires are gone, the buttons are gone. Leave yours, it's just fine. I just want to show you on a nice simple layout what this looks like. After this, we're going to have all of your wires together. You should probably put your display a little further down, somewhere where they don't line up with the buttons. Make sure the buttons have their own horizontal lines and your display has its own horizontal lines. We have to add 4 wires here, and I'll put my power and ground back in. And this time it's really important that for power, you do use the 3rd one down, and I'll connect power and ground down here. so that I can add power to the VCC, and I can put power on the power rail. I can put ground on GND. Oops. There we go. And put ground on the ground rail. And now we have SCL and SDA. That's the communication protocol. We don't need to go into that. All we need to do is choose two new colors. I'm choosing yellow and green. Green, I'm going to have on SCL. It's the second pin from the bottom on our display, and it's the second pin from the bottom left on our chip. SDA is our bottom pin on the display and our third to bottom pin on the chip. And when we look at the diagram, our yellow line is going to be pin 6 or P6. Our green line is going to be pin 7 or P7. Now we're going to add the code. So this code is called hello world display.py, and I'm just going to add it into Tawny, into the code.py file. As usual, I'm going to click stop. Now I'll click save. And when I click run, it's going to error out. Sometimes you can see the error and sometimes you can't. But the reason it has an error is because we're asking it to use a library that we haven't added to the chip yet. So there's a file called SSD1306.py in our code, and I'm going to grab that, create a new file in Tawny, and paste it. Click stop, save it to Raspberry Pi Pico, and it has to be by this name, SSD1306.py. Click OK. For me, I'm overwriting it. I just did this again. Go back to the code.py file and press run. And now on our chip, we see hello world. It doesn't flicker, it's just my lighting right now. Now it's time to build Baby Tetris. Okay, I'm really excited about this part. Now I'm going to put back the two buttons. So again, I want the buttons to be horizontally by themselves and the display to be horizontally by itself. Now all we have to do is take the code called tetris.py and paste that in on code.py. We're going to stop what's running, save, and run. This won't work because we need another library. And that one's... Do we? Why aren't you running? Oh, it's running! I've been doing this too long. So let's play. I have these set up right. Okay, now that the code actually works, okay, we're gonna play for a level, and you can see that I'm cheating. I'm cheating because I actually can't see the screen that well, even with my glasses. So if you have 70% of all of one line covered in your game pieces, come on. It actually works. That's all it took. If you made it this far, I just want you to know that however long this takes you, this took me 4 nights, and I wrote it with ChatGPT's help. So now I want to show you how you can cheat better than I did and how you can add to the code. So let's go look at it. Usually when I read code, I don't want to read top to bottom. I want to read start to finish. And the start of this code is down at the bottom. It's game loop. All the code's ever going to do is continue running this game loop. And the game loop says we have this variable called playfield. That's when a shape finishes, it gets marked down in the playfield as this is its final spot. Then we build a current shape, and we're going to mount this at the very top center, and we're going to drop it and let the buttons move it side to side. For our monitor, we're going to fill it with 0, means blank it out. And then we're going to check if a button was pressed. And when the button gets pressed, we'll go to that code, but it moves it left and right. And then we ask if there's a collision, either left and right or downward as it moves. If there is a collision, we know this shape has stopped moving, so we transfer it over to the playfield of final positions, and then we ask if we have to clear the row of Tetris, because if the whole row's been completed, clear it out, bring everything down below. And then we set our current shape to a new shape at the top center so it can start its path. If there's no collision, that's the else, we just keep moving it downwards. Then we draw the playfield, which means we draw all the previous shapes where they landed, and then we draw the current shape. Finally, we call OLED.show, which means everything we've drawn hasn't gone to screen yet. It's just gone to memory. The .show function puts it on the screen. Then we wait a very short amount of time, change this and see how the gameplay changes for you. And then that's the whole loop. Now I'll come up to the top. Okay, what's happening is we have our hello worlds that you've seen. We have the left button and right button, and then we communicate with the screen through I2C or I2C. And then our screen itself uses that library that we used on the other hello world. So on my screen, it's very wide and skinny. I turned it 90 degrees so I can have more of a Tetris feel. It's narrow and tall. And that's what I'm setting up here. I'm also making my shapes larger than a single pixel, making them 4 times larger. That's my scale. And then I'm drawing the shapes. And when you look at it, there's the bar, and this array looks like a bar. The O, or the square, is just a square array. The L looks like an L with the ones. The Z, if you look where the ones are in our array, it looks like a Z. Same thing for the S. Then that playfield of where the final shapes rest, we create a 2D array based on the scale we're using. So we have the width and the height, and we create that playfield. Then we have our class of shapes, where the shape itself is the letter we've designated, and where it is on the X and Y coordinates. X is left, right, Y is up and down. And then we draw. When we do the check button, that's nothing more than our hello world for buttons. And for the rest of them, you'll be able to see where I was cheating, because on clear full rows, I set a threshold. The row doesn't have to be full, but if 70% of it is, we clear it out. And so that's how I wrote Baby Tetris. If you want to add to it, I really want to see what you're doing. Show it to me and I'll add it into the code. And thank you guys for watching the video. It's been way too long since I made one, and I really appreciate you watching. And this has been a lot of fun.